Hello, so today we're going to look at trapezoids. So a trapezoid, as we saw before, is going to be a quadrilateral in which opposite sides, it has one pair of opposite sides parallel, meaning that they would never intersect no matter how far you extended them. So, for instance, this is a trapezoid. These two sides are opposite of one another and they would never intersect if you extended them out. Therefore, they're parallel. The other two would intersect at some point. All right, so here's a trapezoid. And a lot of times you may see in drawings it denoted this way, meaning to let you know that these two sides are parallel. Um, Generally, you can tell from the drawing, or they tell you that it's a trapezoid. Most of the time, this is seen inside of buildings. Um, Now, trapezoids have some very interesting properties. First and foremost, these two sides are parallel. And generally, if you draw from the end of one to another of the parallel sides, you can draw a rectangle within it and then find out some cool things from there. However, the most, well, I guess arguably, the most important thing about a trapezoid, or a characteristic of a trapezoid, is not that it can just be broken up into rectangles and then triangles, but that it has this very cool principle or property. When you look at going halfway between it. Now, let's first talk about the sides of it. So the two parallel sides are called bases. So this would be base 1, this would be base 2, or you can call that base 1 and base 2. Doesn't matter, but those are the bases. The others are called legs. Okay? So similar to when we were looking at triangles. Whenever we had we had like an isosceles triangle, we had our base, then we had our base angles, and then we had our legs. Similar to that. But there's a special property with going in between the bases, directly in between them, in the middle of them, or the median of them. Okay, so this line is called the median. And what it is kind of an average of, if you were to extend this out, for instance, and go over it, would be how you would create the two equivalent rectangles if you were to split it up. So that's what a median does. It kind of gives us an approximation, and from it, we in a way can do lots of things. We can find the area of a trapezoid, which we'll talk about later, but we can find it based off of the median, um, and do some things actually the same as if it was. We could treat it as if it would have been a rectangle with the side opposite sides being the median length. Anyway, we'll discuss that later. But this median is very important. So it's also very important to figure out, how do we find it? Well, the median is directly in between the two bases. So if we know where that point is, we'll know what the median is. So the median is the average of the two bases. In other words, the median is equal to base 1 plus base 2. And once you're done adding that up, divide it by 2. And that will give you the median every time. Well, that makes sense. If this was 9 and this was 11, 10 would be the middle between 9 and 11. If you add 9 plus 11 together, you get 20. You divide by 2, you get 10. And that's exactly how this works. So it's very important for you to understand the median and also how to find it. In regards to the legs, some more things that people generally would do is they can draw from here triangles to find out the height of the trapezoid, and they can find out other measurements as well. Maybe find the angles using trigonometry, which we've discussed already. So, but the most important part here is the median. So let's look at some examples of finding the median, shall we? So I'm going to draw another trapezoid. Okay, so here's a trapezoid, and I want to find the median, M. And I know that this is 6, and I know that this is 13. Well, how would I find M? Well, we're going to be looking for the number that's halfway between 6 and 13. Okay, so another way to say that is let's add 6 and 13 together. So 6 plus 13 and let's divide by 2. Well, 6 plus 13 is 19, and when we divide that by 2, we get 9.5, or 9.5. So the median would be 9.5, because that's halfway between 6 and 13. Okay, well, that's simple enough. And that's all it is, actually. It stays that simple. What is this for, though? Well, the most common thing that I've seen in my own personal life is when looking at a building. So I'm going to erase this now. So let's say, for instance, we have this building. And this is a wall in the building. And we need to put a column directly in the middle here. Well, this is obviously a trapezoid. How do I know that? It's a building going straight up, so these two sides need to be parallel. Okay? Well, not only that, I know that I'm looking for the middle of it so that it can stay level and hold up maybe that piece of roof. So in this instance, then, I'm really looking for the median. Well, let's say I know that this is, let's say this is 7 feet high, and let's say that this is 11 feet high. How do I find how tall the column needs to be? Well, all I have to do then is add 7 and 11 together. So 7 plus 11, and then divide by 2. So 7 plus 11 is 18, divided by 2 is 9. So the height of the median would be 9. Well, that's fairly simple, right? Yes. Now, there are other times where I've seen that they need to put columns also a quarter of the way through and then 3/4 of the way through. Well, that makes it a little harder, right? No, because if we were to just cover up this side here, we really just have another trapezoid with 2 parallel sides. And that quarter now really is just the median of the first trapezoid. So to find this, I'll call this M1 and I'll call this M2. So to find M1, we can just add 7 plus 9 together. And 7 plus 9 divided by 2 will give us 8. So that would be 8. And then over here, if we just cover up the first part, we see again that we really just have another trapezoid with our bases 9 and 11. So for M2, or the 3/4 of the way through, would actually just be the median of 9 and 11. Well, what's in the middle between 9 and 11? Well, if we take 9 plus 11 and divide by 2, we get 10. So M2 is 10. And from this, as you can see, no matter how wide our wall would be or building would be, no matter what we're doing, if we have a trapezoid, we can continue to find out where should we place these column stacks so that it will be able to support it. And we can do all of this from knowing that it would be the median of a trapezoid. Okay, so this is one of the most important principles of or properties of a trapezoid, is that it has a median. The median is in between, the length of the median is in between the length of the bases, or it's the average of the length of the bases. You add the bases together and divide by 2. So how else can we use this? Well, let me erase this here. Another common way that the median is used is, let's say, for instance, we have a trapezoid. And I know that the median, for instance, is 6.2. And I know that the base, or one of the bases, is 11. Okay? So I know the median is 6.2, and I know one of the bases is 11. What's the other base? Well, first I need to figure out, is the 11 the smaller base or the larger base? Oh, that's quite obvious, right? Well, why? Because the median should be in between the two bases. So if one of the bases is 11, it must be the larger base. Okay, well, how will I find the other side? A lot of people have a lot of different methods for this, and that's fine. You can find out the distance between these two by doing 11 minus 6.2. And in this case, we would get 4.8, and then take 4.8 away to get the other side. That's one way. We can also use our formula for median and say, okay, 6.2 has to equal 11 plus our unknown base divided by 2. And we can solve for x that way. So either way, we can find out what the other base should be. So I'll do it using the algebra method since it's what we've been using most often. If you want to use it, we'll do both actually. So if I want to solve for x, I'll erase the formula down here because we won't really need it anymore. Okay. So if we were to solve for x, we would multiply both sides by 2 to get rid of the 2. Because we need to get inside the parentheses. Remember, order of operations backwards. So 2 on both sides, and that would be 12.4 equals 11 plus x. And we would subtract 11 on both sides. And we end up getting 1.4 equals x. Okay? So the base up here would be 1.4. Well, let's see if we get the same thing doing the distance between 11 and 6.2. Okay? All right, so if we do 11 minus 6.2, we see that the distance between the median and the bases should be exactly 4.8. Well, if we take 6.2 and subtract 4.8, let's see, what do we get? We get 1.4, and that's exactly what we said it would be, right? Yes. So if we're given the median and one of the bases, we can automatically find the other base. If we're given the two bases, we can automatically find the median. So given any of these two, we can find the other at any time. All right, so that's pretty cool. So I also said you can also, with trapezoids, you can use things that you've learned with trigonometry in order to solve for other pieces, and that is true. So I'm going to erase this now. And just kind of leave an open-ended thing for you here. So let's say we have a trapezoid. And let's say that within this trapezoid, that this is 60 degrees. And let's say that this is 80 degrees. Okay. Let's also define the other sides here. So let's say that this is 120. Okay. All right, and then let's say that this one is 100. Okay. Well, because I know some things about triangles, what I could then do, if given some sides, is I could split this here, so this formed a right angle. Split this one, so it also formed right angles. And what I can end up doing is having, and I'm just going to kind of redraw this a little bit so you can see it better. It's having this rectangle where inside here would have to be 30 degrees because that was 90 and this was 120. So that'd be 30 left over. And inside here, 80 degrees. And then I could find my other side very easily, right? Now this one isn't really up to standard. This doesn't have to be 90 on a dot. I kind of just made up some things just to kind of show you what we could do. As again, I said I would leave this kind of open-ended. So this would be 60 here, and then we could leave 90 there, and so on and so forth. But we could solve for different parts of these trapezoid now. We could find the angles, we could find sides based off that information. Okay, so just kind of like I said, again, let that open-ended for future practical applications. We won't talk about doing that necessarily in this class, but it's just kind of something cool to kind of think about. If you know enough about triangles, which you learned about in trigonometry, and you can then change this trapezoid into, say, a rectangle and then manipulate its other sides, then, hey, you can find out everything else that you need to know about the sides if you're given just one of them. Right? So that's pretty cool. So I'll leave it at that. And that's trapezoids. So the most important part with trapezoids here, honestly, is to remember the median. The median is the average of the bases. So if you add two bases together and divide by 2, you get the median. And if you know the median in one of the bases, you can find the other one as well. So that's trapezoids, and I'll see you soon.